our four or three speakers of this session, they kept tight to the schedule, so that leaves us some time for discussion now. Before we start that, I would like to ask all speakers, the audience who wants to make a question and the speakers who want to answer it, to get close to the microphone before starting talking. So, who wants to ask a question? Please come forward.
My name is Arnold Mulder from Amecon in Delft. I have a question to Mr. Roest. It is a very interesting concept, I think, because through the years I know this A stage is producing a lot of sludge, which can be digested. In the current situation, this sludge is thickened and then digested. But in your concept, I have two questions, because what is the concentrations you want to have in this A stage? You seem to know not yet, I believe. And the second one is, you get then the sludge out, and how would you then go and to perform your anaerobic digester? Are you also going to concentrate this sludge? But because in the current situation they concentrate it to, I think, about 4 to 5%. And what's your aim? How do you look to this question? Want you to use the existing digesters, or want you to make new concepts? Thank you.
Thank you for your question. Indeed, it's an interesting question. We also thought about this and discussed already. We don't have really set goals, but we hope actually that it's even possible to have indeed high sludge concentrations in the A stage, and that it hopefully it might be possible to have, without thickening, the sludge transferred to the digester, and then also the digester with a dynamic membrane. You separate the hydraulic retention time from the sludge retention time. So this concept could be very interesting for the application you described, but we haven't set really the goals for the concentrations.
I'm S.K. Hong from Korea University. Actually, I have a question to Dr. Lust. Is that correct? I have a question regarding forward osmosis membrane system for the concentrating your sludge. I totally agree with you on the fouling reversibility and then the less fouling with the forward osmosis membrane, because it's not pressurized systems. And so, based on my experience, yes, I mean, it is less prone to membrane fouling. But however, I'm not sure about energy saving with the current FO technology yet. The usual magnesium chloride is the best draw solution for your system, and I mean, based on your presentation. And how are you going to separate your magnesium chloride from your water?
Also, thank you for your questions. About the fouling of forward osmosis membranes, we see in our experiments that after short-term experiments, actually, it seems very reversible, and that's promising. And also, if we read the literature, there are a lot of studies about fouling with forward, or not a lot, but because there are not yet so many publications about forward osmosis, but there are quite some publications also that mention that fouling is relatively lower compared to other membrane systems, and why this is lower is still also under discussion. But one reason could be, like you explained, the hydrostatic, the pressure of, for example, RO systems or other ultrafiltration systems. And then about the energy, you're right. If you use, for example, a salt for forward osmosis, and then the forward osmosis module will be energy friendly because it's a natural process. But then after that, you still have to reconcentrate your salt and produce your clean water. And that's usually an energy intensive process. You could apply, for example, reverse osmosis or other desalination processes if you use salts in your draw solution. And in our project sewer mining, we could gain some or maybe even all of the energy from the organics from the sewage. So that's why it's an interesting whole concept. And you can collect these organics with an influent fine sieve, for example, where you already collect a lot of organics, the suspended solids. Yeah, maybe you can also up-concentrate the sewage in such a way by extracting so much water that also the concentrated sewage can be digested. But it's all still not yet applied. It's still lab work, so we have to make a lot of steps, and also with the forward osmosis membrane, still a lot of steps have to be taken to make this commercially applicable.
Arie with the Venenbos. I also got a question for Mr. Roest. In your forward osmosis, in your sewage mining concept, what are your ideas with nutrient removal?
So if you have a concentrated organics stream which goes to the digester, then in the digester you will convert the organics to biogas, but the nutrients stay in the effluent, but it's still a concentrated stream, so it could be very beneficial for gaining, for harvesting the nutrients. And there are some technologies for this, of course, like screw-fried precipitation and other technologies, which are also still very often not applied because of the economic factors. So it's still more expensive than producing nutrients in conventional ways. But for example, with phosphorus, we know that it's a limited resource, and it could be even finished much earlier than the fossil fuels. And we need phosphorus for crop production. So maybe in the near future it will be also economically feasible and possible to harvest nutrients from concentrated streams.
I have a question for Maxime Remy. I understand that adding powdered activated carbon made the system more robust, less stress sensitive with respect to salt and temperature.
Yes.
Can you explain it a little bit? I can understand that's less sensitive to toxic organic micropollutants, but why salt and temperature?
Because the idea is that thanks to this activated carbon, you get some stronger flux, and then you, for the salt, instead of relying on multivalent cations to make the flux bridges, you do have another way of creating your flux. We found also the sludge to be more hydrophobic, so you do have some other flocculation mechanisms which make the flocculation less sensitive to the salt. And for the temperature, it is also something to do with the stronger, more compact flux. And in the case of high decrease in temperature, the fluxes I showed were corrected for viscosity of the permeate. But you still have, in the case of stress, release of EPS and compound that can be foulants. In this case, when you don't have so many within your flux, because it's more compact, there are not so many to get released, and then you don't get this fouling. It was in case of short-term effects. In long-term, might be a bit different. That's why it would be interesting to see.
So, any more questions?
My name is Kim Palmo, Technical University of Hamburg. I have also a question to Mr. Remy. The activated carbon has a very high inner surface, but actually, as I understand, you do not need the inner surface. Have you tried any other powders?
I did try non-activated powdered activated carbon, which is just carbon powder. What I find interesting with the carbon is actually the density, which is quite close from the flux. So instead of a sand that would settle quite easily, with the carbon, it stays within a suspension, and then it makes more likely. I did those tests with powdered carbon when I was investigating the mechanisms in order to see if we had a similar effect with non-activated compared to activated in order to rule out the adsorption. And I did find also positive results in that case. I didn't check it in long term and in a pilot. I just did some fast tests with it, but it looked promising. So powdered carbon might have the same effect.
Thank you. I have a question for Mr. Holba. Although you tested the E. coli removal just on a small scale yet, do you have any idea about the cost compared to, for example, chlorination?
Okay, so thank you for the question. The cost, we were trying to calculate the square meters is about twice or 3 times cheaper than usual membrane. So, for example, when we are also now trying to make from nanofibers, we are trying to make membrane and try to make like some low cost way of the water treatment.
So any more questions? If not, I would like to ask Mr. Holba a question myself. In the drinking water industry, we were taught that E. coli bacteria are not the real pathogens themselves, but they are indicator for pollution, for fecal pollution. So I wonder if you reuse wastewater, does that law apply still? Yeah? Or do you have to investigate also the real pathogens to be safe?
Of course, we have to do also other pathogens. This was only just example. We tried only 5 main kind of bacteria which are in most of the standards and directions.
Okay, thank you. So, are there any other people in the audience who want to ask a question to one of the speakers?
I am Matthijs Oosterhuis from Waterboard Regge in Binkel, and I have a question for Mr. Roest once again. Can you imagine that dynamic filtration of A-stage sludge is also applicable to the water which is coming from primary clarifiers when the surface load is very low? We have wastewater treatment plants with primary clarifiers which have a low surface loads, and if I remember it well, it contains about 70 milligrams of COD in the effluents and suspended solids similar. Would this be an option? Then the applicability is much bigger, of course, of your technology, and could be very interesting.
So application of dynamic filtration of the stream from the first clarifier, from the primary clarifier. Yeah. That could be maybe more difficult, but it could be very interesting to investigate. And it could be more difficult because you need the formation of a dynamic membrane. It would be nice if you have actually big flocks, and if you have it after the clarifier, you might already have lost the big flocks and maybe have only very small particles, which are also for membrane filtration very often a cause of clogging. And I'm not sure how that will work with dynamic filtration. But on the other hand, in literature we have seen a study about dynamic filtration of surface water. And I don't know exactly the quality of that surface water, but also in surface water you do not expect a lot of big flocks actually. And I don't recall exactly the results, because I think they didn't have a very good quality of the filtrate. Still quite some suspended solids, but yeah, it's possible that you gain more organics also if you apply it after a primary clarifier. But and then the next step, which I also have in mind, if you want to apply, if dynamic filtration works well and you want to apply this also more often, then you could have the conventional wastewater treatment system with a primary clarifier. You could rebuild the primary clarifier into a sort of A stage. So then you have to apply some aeration in the primary clarifier, and you actually make an A stage. So,
Thank you.
yeah.
So, if there are no more questions yet, that leaves me some time for some final remarks on this morning. Water industry is facing huge challenges on fresh water and energy getting scarcer and scarcer in this world. The scarceness of fresh water makes it necessary for us to look for new sources like brackish water or wastewater. But unfortunately, the techniques to treat the existing techniques to treat these sources up to drinking water are very energy expensive. This morning we saw some interesting ideas on how to use other sources and reduce energy consumption. Mr. Holba showed us a way to disinfect wastewater in order to reuse the wastewater for other purposes. After that, Mr. Remy showed us a way to increase the prestations of an MBR with less energy. And at last, Mr. Roest showed us an total concept of a way producing both energy and high quality water out of wastewater. All kinds of interesting ideas. I think if we go on like this, we can meet these challenges. I would thank you all for your attention, and the speakers, I would thank them for their presentations. At last, I would give the word to Jan-Peter van der Hoek, who wants to tell you some things before we go to lunch.
Arie, thanks for chairing this session. Well, I was asked to give the floor to Weren de Vet because he wants to say something about one of the posters outside. A very nice poster, and he has some comments on it. Weren?
Yes, well, I'm in between lunch for you now, so I'll keep it short. I want to draw your attention to a bit of a peculiar poster in the next room. It's actually not a poster, but it's a video presentation on a new innovative cleaning technique for piped systems. It's in the left end corner of the room, and it will be playing during all breaks, and there will be, either I will be there or one of my colleagues of Oasen will be there to welcome you and to answer your questions. It's a technique that I would say discovered in the United Kingdom a couple of years ago, called ice pigging. So you use ice slurry to clean up pipe systems, which can be a distribution system for drinking water. And we tested it with Vitens company and Oasen company in some pilot project last year. And this year we applied it to a full-scale distribution system, and it really seems very promising. So I invite you to come and have a look and discuss the possibilities with us. Well, that's it for now. I wish you a good lunch.
Yes, it's time for lunch, and we will start again at 2 o'clock this afternoon. Okay, see you then. And the lunch is outside being served.